Good morning. Good morning. Howdy, howdy. How's it going?
Hello. Hey, what's up?
Same old, just another day in quarantine. What about you?
Yeah. Well, I'm a teacher. Um, so I'm on spring break, and I would be at home anyway right now.
Oh, perfect.
Yeah. I'm here because my cousin said you're her favorite programming teacher, and
That's great.
I'm actually trying to switch careers into software.
Oh, right on. So is
Yeah.
this your first programming language?
It's not actually. For the past few weeks, I've been doing a Khan Academy JavaScript program.
Okay, awesome. A lot of
Uh,
this stuff will feel familiar then.
cool. It's been great. I'm at the point where like I've got very fundamental concepts down, and things are beginning to get complicated, and it's beginning to be like much more of a challenge.
Yeah, finally a little fun instead of just like this. Here's the ABCs.
Yeah, exactly. Yeah.
Who's your cousin?
Ginny Foz.
Oh, awesome. Yeah, Ginny. She's a huge supporter of mine.
Yeah. Yeah. Yeah.
Awesome.
So
And
I
now
just
she's in Singapore, right? That's cool.
She is. Yeah. She's at some crazy grad program. That's sort of, I think it shares time between Singapore and Switzerland, I
Oh,
think.
I don't know. She didn't tell me about Switzerland, but that's
Yeah,
cool.
it's like a dual. It's definitely a dual location program.
Hmm,
Um,
right on.
yeah, yeah, yeah. She's cool. I'm inspired by her choices.
Driven.
Yeah, for sure. I was looking through your curriculum. I'm really impressed with how organized this is.
Oh, thank you.
Yeah.
You know, this little thing, I'm going to extend basically what we've got on the GitHub to like an 8 class course instead of a
Okay.
1 day workshop. I'm excited to do that. It'll be a little easier for the students. 1 day to cover all this is a little overwhelming, at least last
Yeah.
time I taught it was.
Well, I'm also very strongly considering a boot camp.
Okay.
And I figure this with how much material you're planning to cover in 3 hours, I figure it's a decent toe in the water for what a boot camp might be like.
Yeah, absolutely.
Yeah,
Where are you located?
I'm in Portland, Oregon.
Okay, so I guess there's not a Galvanize campus there. I used to teach at Galvanize, so if you want some advice about boot camps, you know, I've been in that industry.
Cool. I've Portland's options seem okay. There's sort of three big ones. There's one called the Tech Academy, which is they have a full remote program, but they also have their headquarters in Portland. I have a friend that went through that program and is very happy and successful now. So that's probably going to be the one that I pick. But there's also one called Epicodus, and there's one called um, Alchemy Code Lab.
Hmm.
Yeah, those are the ones that are local, and I was looking for something local.
Yeah, I mean, makes sense.
Yeah, I want to. It's nice to have a teacher, like a person that you can like go to
Ask.
ask questions.
Exactly.
Yeah,
Instead of trying to ask Google and being like, which of these three is
yeah,
reputable, you know?
yeah, yeah. And
Oh,
with actual content, I've
yeah,
struggled with some stuff on Khan Academy too.
just kind of weak.
Well, yeah, like people, there's the community is pretty responsive when you ask questions, but you still have to wait.
Yeah,
Like if I get stuck and I really can't figure it out using the internet, then I'll ask a question and I have to wait till someone responds, which usually
sure
is
might
like
be
within 2 hours, but I have to sort of
still
put it
two
down.
hours. Yeah,
Yeah,
you gotta walk away.
right.
How long are those courses you're looking at? Are they like the 12-week, 6 week?
Yeah, the full time one is 22 weeks.
Oh, nice. Actually pretty
Yeah,
lengthy. That's good.
it's about 5 months. Yeah.
I always thought the The short programs are just a little too ambitious.
The boot camp is a 22-week program.
Hmm.
That's what you're talking about, right?
Yeah, yeah, yeah. I mean, like
Okay.
Hack Reactor, the first one that opened that I knew of, or Dev Bootcamp was first. They were only like 12 weeks. It's like change your career in 12 weeks.
Yeah, it's
Oh,
wild.
well, that's a lot.
Yeah, that's a lot. Um, yeah, so thinking about doing it in the summertime, and what I'm trying to do now, especially with quarantine, is get sort of as much foundation as I can on my own, because there's so much stuff available for free on the internet.
Oh yeah,
Um, so just trying to give myself like a decently self-taught foundation to make the boot camp go a little smoother and perhaps quicker.
yeah, yeah. I think that's good. If you come in with a little more understanding, you'll be happy for sure.
Yeah.
Looks like it might just be the two of us. I tried to do some advertising, but
Hey, that's fine. That's cool. I'm really excited about this,
good,
and I'm probably gonna have lots of questions too. So
perfect. Yeah,
yeah.
well, I'll wait until like 10:05 and then we'll get going.
Okay. Cool. I've got Visual Studio Code downloaded.
Nice. And were you able to get the Python extension as well?
I think so. I'm new to the program, so I think I did.
Okay, cool. Let me switch screens real quick here.
Let's see. I think I can.
So if you open
Oh,
up Visual
cool. Okay.
Studio and you just do like a new file, save it as something .py, temp.py.
Okay. One second. I have to figure out how I want to do my screens because right now I've got them. I'm on a MacBook, so
Yeah, you're just looking at one. I've
I've got
got
them.
three.
Oh, nice. I actually can tile them, which is nice to the side. So I got Visual Studio Code over here and and Zoom over here.
Mhm.
But then I just need to figure out what to do here. Oh yeah, okay. The only so I get a notification that says linter pylint is not installed.
Oh, install that. It'll be helpful. A linter
Uh,
is like spell check for your code.
oh, cool. Okay. Okay. I hit install. It says there's no pip installer.
You're on a Mac?
Yeah.
Weird. Do you have like a little, did it put a terminal output here for you when you said install Pylint?
No, it's actually so I have the Python extension installed because it says the source is the Python extension.
Yeah, well, pip probably won't be a problem for now, but you might not be able to get the linter without pip. So
Yeah, I don't.
ignore those two messages for now.
Okay.
And then make a new file called temp.py.
Okay. I made one called tempsworkshop.py or
Sure.
tempsworkshop.py.
Yeah, perfect.
Very cool.
And then do you have a little arrow button in the top corner here?
Um, hold on, let me. Oh, that's cool. Sorry, one sec. Zoom. When I sort of switch between screens, Zoom keeps the videos open.
Oh yeah, totally. Hey
Yeah.
Jess, welcome. Okay, anyway, Lenny, you got this little button here.
Um,
Jess, I
is your
told Lenny we'll wait until about 10:05 to get started in earnest, but we're just working on our environment.
where's your mouse?
In the top right corner.
Oh, that little green. Yeah, I
Yeah.
have one of those.
Then you should be good to go as far as environment. If you write some code that looks like this, print hello, and then you click run, you should see down here, hello should appear, and you can clear that screen and then run it again, and you'll get something a little cleaner.
Um. Oh yeah. Okay.
Cool. If that's it, then you're good to go.
I think so.
Jess, what about you? Were you able to install Visual Studio Code and the extension?
Yeah. Yeah, no problems.
Right on. Okay, well, I think we'll wait like 2 more minutes and then this will be a great little class of 3. We'll learn a lot.
Cool.
I think more will join.
We'll see. I don't know. I don't have a huge A, advertising budget or B, reach, but it's good.
Hey, Jess, my name is Lenny.
Hello.
Jess, how did you hear about us?
I did the AI camp deep learning course that
Oh,
you
you're
did.
you're Jess from
Yeah.
LinkedIn. I know you
Yep.
know.
Yeah.
Welcome. Now you took the Python deep learning course, but now you're here for the intro to programming class. That seems surprising.
Yeah, so here's the weird thing. I've self-taught myself Python, so I have these weird gaps. I essentially learned exactly what I needed for data science and machine learning. So
Oh,
there's a lot of weird things that I don't actually understand how they're working, but I do know how to write them anyway to make what I need work.
okay, awesome. You and Lenny are going to be an interesting combo. Lenny, tell Jess a little about your background with programming.
I am pretty much brand new to it. I am trying to do a career switch probably sometime this year. And I'm a teacher, and I've done a little bit of self-teaching with JavaScript on Khan Academy, and that's it. That's as far as I've got. So
Hey,
Very
Trey.
I'm a noob.
Hello,
Welcome.
thank you.
Were you able to install Visual Studio Code, Troy, and the Python extension?
Yes, I actually, so this is a refresher for me. I took your class at Starbucks
Oh, right on. Okay.
last fall. So,
That's funny. We're going to work through the same material, Troy.
yeah, that's great. That's perfect.
Okay, cool. This is a good little group then. It's 10:05. If a few more people show up, we'll let them in. We've just been talking a little bit about basically what the first thing on our agenda was today, which was, to ask you all, why Python and why code? Why are we learning this stuff? Let's get the context in our minds before we move on. So, no reasons. I mean, Jess is doing a bunch of machine learning stuff I already know. Lenny's looking at a career switch here, maybe. Troy, give us your background. You're at Starbucks.
Yeah, I've been a Windows system administrator forever, but yeah, tired of being on call and whatnot, and so I'm moving more into Scrum Master and um, project management stuff. But this class and is helping me better understand what the people I work with do, and just broaden my own skills as well.
Sweet. And why Python? I mean, there's a zillion programming languages we could learn. What are the strengths and weaknesses of Python as you all understand them?
From what I can tell, it's pretty versatile.
Okay, I think that's absolutely true. My joke about Python is that it's the second best language for everything.
The first being English. What's the
Well,
first?
no, the first being something different that's specific to the domain. So Python
Oh,
is
okay,
never
got
like
it.
the absolute best. Oh yeah, you always use Python for this, but you can use Python for anything. You can build web servers in Python. You can do data science in Python. You can even do like some low-level programming, like with a Raspberry Pi. You can do microcontroller stuff in Python, but it's never, it's so flexible that it's never really going to be clearly the best.
Oh, okay.
Although, I don't know, I'm starting to feel, and maybe Jess, you have a feeling about this too, that in the data science, statistics world, Python is really forging ahead.
Yeah, it definitely is because there's starting to be a real focus on full stack data science, which is getting it all the way out to deployment. And that's when I realized, oh, okay, so I sort of have a delusional feeling of proficiency in Python. when in fact I really just memorized certain functions and patterns. And so I thought, okay, I don't mind being a beginner. I'm just going to go square one and just kind of catch myself up. Because once you get to that side of things, then it's definitely Python full steam.
For sure. And when you say like full stack data Python for, Jess and Troy, I think, or sorry, for Lenny and Troy, that might be a little new. What do you mean by that?
So typically in data science, or at least where my starting point was, I was looking at doing a lot of statistics and modeling and making deep learning models using some frameworks that you can kind of just remember to yourself, what are the steps of running it, and so you can in a way kind of memorize that code. But then like let's say you have you've built a model and it's going to do a really great recognition of whether something is a dog or a cat, and that's fine, and it's sitting on your computer. So it now has to get out into an app form or out on a website or something for people to use it. And so
Right.
when you take it like kind of all the way to that level, then that's considered the full stack data science.
Totally. And so, here on our situation, we've got like a bunch of pictures of dogs and cats or whatever, and then we've got our code, and then our code runs in our computer, and then we upload a new cat photo, but it's already on our computer, and our computer's like, it's a cat. But right in the real world, it's like, well, okay, actually, you've got a database over here with all of the cat pictures that anyone's uploaded ever. There's a web server that kind of wraps that database and exposes a web server for our users to use. Our users need to be able to use their laptops and send our web server a photo of a cat, question mark, right? And then get back over the internet a response from our web server that says, actually, no, that's not a cat, that's a dog or something else. And this database needs to be able to, in the machine learning world, have like millions and millions and millions and millions of records in it. So it's got to be kind of high performance. And before you put that model, here's their statistical model is just part of this web server. You also needed to train it, which you might have wanted to do on specialized hardware. So, it's very possible you'd have some like big beefy AWS machine that's got a really powerful processor. Compared to this web server, it's not doing hard work. It's just like, oh, a request, process the image, send it back. This is cranking, for days and days with a huge amount of data beforehand. And so in a lot of frameworks where it's kind of, or languages where it's easy to do some of this data science stuff, easy to build some of these models, like MATLAB comes to mind, R maybe comes to mind. Both of those languages are good at doing this. We've got our data here, we've got our code on our machine, let's just run it and find out what happens. But they're both not as good at doing this, building web servers and talking to databases and managing that workflow, receiving information from a third AWS computer. Python's a lot more flexible in that way.
Yeah, and then just as a side note too, a lot of the interviews for data science, which I'm not really in the position of interviewing, but you never know, they're doing a lot more of the coding interviewing because they're wanting data scientists to get a lot more closer to software engineering in terms of the quality of their code. Whereas they used to be just like the Wild West, just write terrible code if you feel like it, it's really inefficient, and then a software engineer will come behind you and fix all that.
Oh, funny.
Because the gold is just the model. You did the model, that's yay you.
And
And
now
then
make
now
an
someone
engineer
else,
clean it up.
yeah, someone else will make that work. Now they're sort of wanting to skip that step, or at least minimize that, where it's like you're handing
Yeah.
off something pretty passable to a software engineer.
Okay.
So they're doing that all in the interview. So the interview is starting to have a component that looks a lot like a software engineering interview. And that's where I'd be really lost.
Gotcha. Okay, yeah, that makes a lot of sense. And then maybe just for you two, Lenny and Troy, to put that into context, like the difference between building a model and writing code, the model is still going to be in some code. So, this is just like, there's an editorial process with code like anything else. Here's your data scientist, right? They write some code, but it's really, really academic and formalized, hitherto, therefore, we should explore the blah, 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 blah. And okay, and then your editor is going to come along this is the software engineer in this metaphor, and the editor is going to look at this and be like, okay, no hithertos, no therefores. When we do this, X happens. You know, let's clean it up. Let's make it simple. When we write the data, it's a cat, blah, 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 whatever. Okay, so there's an editorial process. That's our software engineer. And, you know, in English, right, we're looking for cleanliness and understandability. That's true in software too. As you'll see, you can write code that's really ununderstandable, and you can write code that's much easier to understand. But it might also be for like speed and efficiency purposes. And in today's lesson, I don't have a lot planned for talking about how to make programs faster and slower. There's definitely a lot that goes into it. This is like the Algorithms 101 kind of class. And then also you can talk about hardware, but I've got a lot of interesting links I can share about those two things. And maybe if we go fast, it'll be worth talking about too. And then, you know, after this, maybe you'll have like a final product that's really good and smiley face. And this is what you actually end up shipping. You know, this happy face code is what gets shipped to that web server later on.
Unrelated question.
Yeah.
What program are you using to draw?
This is Notes on the iPad.
Oh, just Notes. Cool.
Yeah, it's pretty good for the built-in app. Ooh. It's better than a real whiteboard because you have, you know, this whole infinite scroll thing.
Yeah.
Anything else about like pros and cons of Python? Why we're doing Python, or you know, why you should choose another language?
Python was going to be my next go-to after JavaScript anyway.
Yeah, it's a great language. And JavaScript's its own like little specialty thing. It's the only programming language you can run in the browser right now.
Okay.
That'll change soon. There's something called WebAssembly that's coming out that'll, I mean, it's a long period. It's already out, but it's not like fully standardized yet. But anyway, for now, if you want to run web apps, you have to write JavaScript. And that's also common, like ecosystems, you know, if you want to write iPad apps or iPhone apps, you need to learn the Swift programming language.
Right.
Okay, sweet. Then what I want to do next is discuss the syntax of Python, and we're going to basically go through a series of examples talking about, you know, how to define variables and data types and what they are, how to define operators and what they are, how to define control flow, and give everyone's background so far. I think this will go pretty fast, but I think we should all make sure we have the materials first. So did everyone have this repository, you know, copied on their machine somewhere?
I just need to download it.
Yeah, click download the zip. If you're a Git user, you know, I don't have to tell you what to do if you're a Git user.
Not yet.
That's another great thing to learn.
Yep, it's good.
What about you, Troy?
Yeah, I have it.
Okay, sweet.
What's actually?
Yeah.
What's the best way to just sort of download all?
Yeah, so go to the main intro to programming page.
Yep.
Do you need me to Slack or channel send that to chat?
No, I already have it pulled up.
Okay. Yeah, then just do download and then do download zip. Save that somewhere.
Hold on, actually. Oh, I was on the wrong page.
Oh yeah, not on the main landing page.
Yeah. Okay.
Cool. And then once you download the zip, you know, you just unzip it, and then you can go into Visual Studio Code, and the best way is to open the whole folder. So I saved it in downloads. Here's the whole folder, and you just open that folder. And then you should have it all here. The first thing we're going to look at is this first code example talking about data types and variables. I can change the Python interpreter. Good for me. Okay, so data types and variables, that's what we're talking about here, and we're talking about the syntax of Python. What's a variable? I think we all know.
It's like a thing that represents another thing.
Wishy-washy, yeah. Can we say more? Troy, what's a variable?
It's the I guess it's the data, your data. It's your, you know, whatever you're trying to gather and manipulate.
Okay, yeah, we're on the right track. Jess, you want to try and give an even more precise definition?
So a variable is basically a storage for a value.
I like that, yeah. It's a place to put some data, absolutely. And data can come in many forms and types. You know, we have two variables being created here. They're both poorly named, X and Y. You know, what the hell does that mean? Should always try and, you know, when we have examples that aren't just contrived examples to show the syntax of Python, we should at least try to have names that mean something. Remember, we're writing code for the computer, yeah, but also for the human, okay? And so I think of variables either, I mean, there's lots of metaphors you could use. It's like a box and you put some data in the box. That's a fine metaphor. It's like a tentacle and the tentacle grabs on to the piece of data. That's an okay metaphor. But either way, you know, it's a name and we use that name to reference some value that we put in that named thing, that variable. So in this case, X is a variable and it currently contains the value 1. And Y is a variable and it contains the value 1. What's the difference between these? One and one.
Single quotes.
This is wrapped in the single quotes, and that makes this a different kind of data, right? So when I print these 3 lines, this thing is going to tell me 1 is a number, and 1 is a string. Okay, where strings are just textual data, mostly meant for display purposes, right? You can look at strings, they can get printed to your screen, whereas with numbers, you know, we'll do math with numbers. We can't do math with strings. It doesn't make sense to do math with strings. We can combine them. We'll see. You can do concatenation and you can like search for data inside of strings. You can search for substrings and stuff like that. Okay. And then in Python, right, this equal sign, and this is common, almost every programming language uses this, equals is assignment, you know. So unlike variables in algebra or whatever, we're not asking a question. You know, we don't have like x equals y plus 7. What are the possible values for x and y? What works? We're saying make a variable x, give it the number 1, put the number 1 into it. Make a variable y, put the string 1 into it. Okay, so this is assignment. It's not a question, it's an action.
In Khan Academy, one thing I've really liked is the way they describe that is that the equals sign is like saying the word gets. X gets 1, Y
Oh.
gets 1.
Yeah, that's nice.
Yeah, yeah.
Okay, cool. So there's 3 different kinds of numbers in Python, different data types for numbers. There's integer data types, 1, 2, 3, 4, 5, 6, 7. There's floating point numbers, you know, anything with a decimal in it is a floating point number. And then we almost never use these, but Python supports complex data types. So if you remember like the square root of -1, for some reason they use j instead of I, but this j means what complex number 1 meant. You'll almost certainly never see this again unless you already use complex numbers in your regular life and you want to, but whatever, it's good to know that Python can do that. Okay, Boolean data, true and false data. These are really, really common to use in programming. And usually you don't just like set a value equal to true or false, but you'll use operators that result in true or false. You know, you'll compare things. Is this equal to that? True. Is this equal to that? False. Okay, so very important kind of data. and we'll see them all over the place. And if we print the type here, they'll be bool. What about this?
I haven't seen that yet.
Troy?
I do not recall.
Yeah, so none is, Lenny, you've probably seen undefined and null
Yeah.
in JavaScript. None is the same as undefined or null. It's a special reserved value that means this thing's empty. There's nothing here. Okay. And we need this sometimes, like if someone fills out a web form and it says first name, last name, but they've got a mono name, then they have to leave one of those blank. So we'll represent none as the
Okay.
value for the blank field. And it's not the kind of thing that we see all the time, but it is the kind of thing that comes up pretty regularly.
Oh, that makes sense. Like when you need something to be, when you need something to like read blank, but it's not blank, like you need a space for it. Does it?
Say again. Yeah,
Is it like when you need the output of something to be like nothing shows?
Yeah, or like there is no correct answer,
Okay.
Either of those would be uses for none.
Okay.
And by default, for example, like if you make a function in Python, def x whatever, this is how you define a function. We'll see that in a second. And you just don't do anything in the function. Pass is a special keyword in Python that means do nothing on this line of code. Then this function will return none.
Got it.
Okay, and then these are strings. Well, this is a
Yeah.
string. Okay, so if we run this code, we get a bunch of text output, right? We had an int and a string. And we can always use just this type function to get the type of anything. So if we're ever confused about what type of data we're dealing with here, we can print it out. We've got this complex number type that you're never going to see again in history. 2 bools, a none type, and finally another string.
So Tyler, for the none type, is it reasonable to say that the main use for that is when sometimes the variable is going to have a value and then sometimes it's not going to have a value? Because I mean, it has to, like, I can't think of a use where it would only ever be none.
Yes, you're absolutely right. It's like someone fills out a form and we have a middle name field and not everyone's got a middle name. So they go Tyler, blank, Batillion. And instead of saying, you could say my middle name is like the empty string. It's just a string with nothing in it. That'd be one option. But it's probably more accurate to say my middle name is none. My middle name isn't a blank string. I don't have a middle name. So give me the explicit no value.
Got it. Okay.
Yeah,
I just want to make sure there wasn't a clever use where it's like always none that I just hadn't thought of in my mind.
Yeah, no, I can't think of a good reason why that would always be true either.
There's a metaphor that my brain is really trying to fit in here that I'm not sure is correct, but it seems like it's correct. In music, a rest is not nothing. A rest is a defined moment of no sound.
That's right. Explicitly don't put any sound here.
Yeah.
Not, maybe not sound.
Right.
Absolutely none.
It's not that nothing is happening. It's that there's no sound over this in this given space.
Yeah. I like that metaphor. I think that's nice.
Okay, cool. That makes sense then.
Okay, cool. So variables, data types, there's different variables, there's different data types. The data types don't really talky. Strings and numbers are different. Let's look at this next one. Okay, so here we can do math with numbers, right? So 2 gets 1 plus 1. Whoops. Right, and then the value of this variable, we can print it out later and show that it'll actually be the number 2, right? Math operations are pretty straightforward. 2 times 3 6, so we should expect this to be 6. 6 divided by 2, we should expect to be 3. These variable names are, good in one way, but bad in another way. They're good in that we know it's 2 at this point in time, but I could later go like, nothing stops me from doing this. And then 2 will be 5, and, we'll all be hosed, right? So this is something I see a lot of beginner programmers get tripped up on, is the names of these variables are completely irrelevant to the computer. They don't know them, they don't care about them, except that you, the programmer, uses them. You type them in and, do whatever you want with them. But this is completely allowed, and the computer doesn't even think there's a hint of irony. It runs that line and it's like, boom, 2 is 5, I'm happy about it, why not? Okay. And, you can do math directly like this. You can do math with variables like this. Here's me making that same point I just made. It's just as happy to do X, Y, and Z rather than 2, 6, and 3. The names are totally irrelevant. And this is, maybe more confusing to some people. We still don't have any, these are all contrived examples, so we still don't have any situations where we have a meaningful variable name, but we'll get there. Okay, now this is new and different. Double equals. What's double equals?
This is one that confuses me. So this would be one of my gaps. Is that sometimes I feel like I understand this and sometimes I don't. I think
Awesome.
it's where I know that it's when you're trying to see if something matches, but I have a hard time understanding why that's different than, is that the value that's stored in there?
Okay, so this is absolutely a question of equality. We're asking, are the values in 2 and x the same value? Is 2 equal to x? Okay.
Well,
Now,
is it a question? Is it a question?
it is a question, and the computer will provide the answer. So here,
Okay.
it'll say 2 equals x, and that will result in either true or false, one of
Got
our
it.
2 Boolean values, which in our case is what?
Is true.
Right? Because 2 is 1 plus 1, and x is 1 plus 1, so they're both going to be equal to 2. So this one's true. What about this one, Troy?
Um, honestly, I'm just guessing, but I would say true as well, based on the error.
Okay. And this will be true because y is going to be 2 times 3, which is 6, and 6 was 2 times 3, which is also 6, right? Okay, and, we can use our pattern matching brains and say, what's this one going to be?
Yeah, true.
Also true, because once again, I did 3 is 6 divided by 2, and y was 6, so this is 6. X is still 2, so z is still going to be 6 divided by 2, which is 3. So all 3 of these are going to be true, and we can always check, great habit for beginner programmers. Just the right way to find out what your code does, the best way, is just run it. Boom. Okay, so we get at the top, I printed, let's clear this out first. By the way, that shortcut to empty this console is Command K, and it'll just clean everything out. Then you can run it again and get just the new. Comparing true, true, true. Okay.
Oh, never mind.
Hmm?
Command K wasn't working for me for a second.
But then it did. If you got to
But then
click
it did.
in the terminal first.
Yeah, yeah.
Okay, and then I printed a blank line, but then this one we see where I'm printing, and this is a little confusing syntax here. This right here prints the string in the console right here. So see this double quote, and then one, double equals one, and then there's a single quote inside the double quote. That single quote's just interpreted literally as the character single quote. So it gets printed down here. So this whole thing, this two parameter print statement just prints this thing as a string, and then it prints the result of this comparison. Okay, everyone with me here?
Yep.
Can you do that? Say that one more time.
Yeah, so this print function, which is what, prints output down here, it can accept any number of parameters separated by a comma. So basically it first prints this string, which it prints, very literally, one double equals quote, one quote.
Right.
And then this is actually an operator in Python. So this actually is a statement that gets evaluated to a value because we're asking the double equals question. Whereas here we're just saying print this string. Here we're saying perform this comparison operation and then print the result of that comparison operation, which is false.
Because the number one does not equal the string one.
That's exactly correct.
Got it. Or
Right,
does
so-
not. That,
Yeah, that's exactly right.
I was wondering if
And-
there's a better way to say that than does not equal, but
No, I think that's right.
okay.
You could say the result of the comparison, integer one equals string one, is false.
Right.
That's like a very literal-minded way of interpreting it.
Yeah. Okay.
Yep, and so we're allowed to compare data of different types, but in Python, and this is, a difference from JavaScript, as you'll see. You have you seen the difference between 2 equal signs and 3 equal signs in
I have.
JavaScript?
Yeah.
Okay. Python is always 3 equal signs. Data that is a different type in Python is never the same value.
Okay.
Whereas this statement in JavaScript would evaluate to true,
Right.
and this one would evaluate to false.
Right.
Okay, so in Python, data of different types can never be equal. Never. Okay, and there's lots of ways that we can do comparisons. Jess, you said you had some, confusion about this equal sign operator from your work so far. Has it been cleared up?
Well, I think it comes in more when you're actually using it, right? So I'll make the mistake of just using a single equal sign,
Oh.
and then I'll get errors, and then I'll think about it to myself and go, oh, it's got the double equal.
For sure. I can't tell you how many times I've debugged code that looks like this. If x equals y, and they mean if
Yes. Yeah.
double equals y, and then, okay, so this actually gives x a new value. X gets whatever's in y. And then if x happens to be a value that evaluates to true, you do the if statement. Yeah, tons of bugs that way.
Yeah.
There are also some interesting double equals with lists and dictionaries that we can look at.
Exactly. Yeah. So that's again where it's coming in.
Exactly. Yeah, complex objects compare somewhat differently than these primitive data types that we've seen. So primitive data types, numbers, plain old strings. Lists are like collections. We'll see them in just a second for those of you who haven't before. And there's really weird rules for comparing lists that differ dramatically from language to language. And it has to do with like the underlying representation of the data on the actual machine itself. So, we could do a computer architecture class here and then get to the truth of the matter, but it can be pretty confusing. So look forward to that. With primitive data types though, the price is the price. These are different data types, they're not the same. 1 is equal to 1 only if they're both integers. We can compare, number data types, and we can compare some, we can do this. So now we're comparing an int to a float, but this will still be true, even though they're different data types. 1, the integer, is still less than 2, whether it's an integer type or a floating point type. But those two values, 2 and 2.0, are interestingly not the same.
So like 2 double equals 2.0 would result in false.
Not necessarily, but I'll show you 2 examples that'll hopefully twist your mind a little bit, okay? So let's go print 2 double equals 2.0. This one, I suspect will be true. I think that'll get that right.
Okay.
But if I go print 0.1 plus 0.2 double equals 0.3, okay? This ought to be true, right?
Mhm.
Let's just print this here so we know where in my console that particular print is happening, because there's other prints going on here. Okay, I ran it. Here's our notifier that we're printing these 2 lines of code next. And like I said, 2.0, 2 equals 2.0 was true. It got that one right. But 0.1 plus 0.2 does not equal 0.3. What? Okay, I can show you what's going on here. And this is, I just touched my face. That was bad, Tyler. We're supposed to be on lockdown. Okay. If I print just the value, 0.1 plus 0.2, run this code. 0.3000000000004. Okay. Basically, this has to do with the limitations of computers. This is not so different from, I could ask you, what is 1 divided by 3 in decimal form?
0.33.
But it's not, it's 0.333333333333 forever, repeating. We don't have in, base 10 counting, we don't have a way to appropriately represent 1/3 precisely. We need to use this mental hack to say 0.3, an infinite number of 0.3s. Similarly, computers use 64 bits, 64 ones or zeros worth of storage to represent all numbers. And it turns out that 0.1 plus 0.2 has a similar problem as base 10 does for 1 divided by 3. We don't actually have enough space, given the representation we've chosen for those numbers, to perfectly represent the math required to do 0.1 plus 0.2. So we have this strange round-off error. Okay, and that happens with floating point numbers, pretty regularly. Who's seen Office Space?
Yep.
Okay, this is the bug that they're talking about. We round off tiny fractions of a decimal, and they're doing these calculations all the time. We're taking fractions of a penny. That's this right here. It's actually a real bug. Okay, and so people have invented special kinds of numbers that aren't the default for doing financial calculations, called fixed point rather than floating point. And with fixed point numbers, you can accurately represent, up to a certain decimal place. So you say, I'll get 2 after the decimal, and whole cents are the only thing we can ever do math with, for example.
Cool. Thanks.
Okay. This is less than, this is greater than or equal to. So 10 will be greater than or equal to 10. This is strictly greater than, so 10 is not strictly greater than 10. That'll be false. You can compare strings this way. Strings are almost alphabetically compared, so if you have all lowercase, then it will be a strict alphabetical comparison, dictionary sorting basically. But using comparisons this way in Python, all capital letters come before any lowercase letter. So capital B is less than lowercase a, which is a little bit weird. It means when you're sorting things in Python, make sure you lowercase your strings We might see an example of that later. But you can compare pretty much anything. And these comparison operators, you do this all the time in your day-to-day programming. You'll have lots of if statements, which we'll see next, that'll say, if some comparison is true, do the next thing, or do the next thing, or do the next thing. And if it's false, do some other thing. Okay, here we're doing addition with strings, which actually works just fine. This is called concatenation. So plus works with strings, but like minus doesn't work with strings. And plus just means put these two strings together. We have hello followed by a space, that's this string here, and then world. The result of that will be hello world. And it turns out in Python, JavaScript, you can't do this. I don't know any other programming language that has this particular syntax. You can duplicate a string. So if I go times 4, I get 4 copies of whatever this string is. So A as a string times 4 is AA. And if it were, AB times 4, I'd get AB, 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 AB. How are we feeling so far? Any questions about this stuff?
I'm good.
I'm good.
Troy, you good?
Yeah, just more, sorry, I'm on call, so I keep getting
Oh, pinged.
pulled away. And so I might have to just drop off and try again next week, unfortunately.
Say la vie. I'll remember not to cold call you until you turn your video on or something like that.
Yeah.
On call, that's tough life.
Yeah, sucks.
Okay, the last operator I want to show you is really common to use when you want to repetitively kind of increment a variable. So you can do any math operator followed by an equal sign. This is plus equals, minus equals, times equals, divide equals, and they extend out to be, x plus equals 1 is the same as saying x gets x plus 1, which is to say increase x by 1. Minus equals 1 is decrease x by 1 and store the result back into x. Times equal 1 is boring. Give x the value x times 1, which will always be x. But if I do x times equals 2, then it's x times 2, double the value of x and put it back into x. Double the value of x, put it back into x. And then similarly, divided by 1 is not that interesting, but divide equals 2 is interesting. Half the value of x, half the value of x, half the value of x. Okay, so this is like an operator and assignment combined into one little thing.
Is this particular syntax common in many languages?
Yes.
Because it's true for JavaScript too.
That's right. And JavaScript also has x++, which is shorthand for x plus equals 1. Python does not have x++, only plus equals. I don't need an S there. Okay, sweet. Let's take a look at if statements in Python. Okay, I don't know why I have x equals 7 at the top of this. I wonder if I use x somewhere down here. No. Okay, that's weird. Can't delete that. Okay, so if I run this code, what's going to happen?
It'll print this executes?
Yes, absolutely. Print this, this executes, but this never executes, right? Because if false, the whole rule of if statements is if the thing following the if statement evaluates to true, do the block of code underneath the if statement. And if that thing evaluates to false, which false does, don't do that thing. Okay, so this line of code does get executed, line 7 here. It gets executed. The result is that line 8 should be skipped. That's what the Python interpreter says, right?
Okay.
This thing here, this indent, I don't know if you can tell, it's kind of hard to see, but I have it showing these 4 white space characters, ... I don't think that's the default for,
No.
so you just see empty space there.
Well, I have the line. I have the indent line,
hmm
but I don't have the 4 dots.
Okay, so there's a difference between 4 dots, 4 space characters in Python, and say a tab character in Python. And that's why I have white space turned on. I can't remember how to do that quickly. I was going to see if there was toggle, if there was something in the command palette to easily turn on white space characters, because I think it's smart to do in Python. Because I have seen a number of times when people accidentally mix and match. They have like 1 tab followed by 4 spaces, and that's not the same as 2 tabs. So you can get some weird Python bugs based on indentation. And this is something that's different again between JavaScript and Python. And Python's the only language that I know of that has this, where white space matters. The white space characters are actually interpreted by the interpreter, and you care about them. In most other languages, you set scope another way. But so this line of code, everything that's indented 4 spaces underneath this if statement is said to be this if statement's scope.
Okay.
Okay, cool. So plain if statements, pretty easy. If true, then do it. If false, then do it. Which again, we could say like if 1 equals 1, or if, more realistically, some variable of mine equals 1, this executes, which I think is actually the example just below here. So, okay. So we have some arbitrary number. We're saying give arbitrary number 42. And then we say if arbitrary number is greater than 10, print something, else print something else. So which of these 2 executes in our case?
The first one.
Right, because arbitrary number is 42, which is more than 10, so we'll print this one. And the way if else blocks works is only one of the 2 things can happen. If the thing is true, do the first thing, do the thing for the if. And if it's not true, if this evaluates to false, do the other thing.
I am sorry to go back a step, but I found the settings for the white dots for the white space.
Oh, beautiful.
And so would you mind just explaining the difference between tabs and spaces for Python again?
Right, so indentation controls the scope of an if statement. So in JavaScript, for example, you probably used to having curly braces.
Yep.
And the curly braces control the scope. And you could have code that looks like, this and this and whatever. It's ugly, but it would work just fine. And all 3 of these things would print.
Yeah.
In Python, if I get rid of the curly braces, which aren't Python syntax, and then I try to run this code, I get an error. Indentation error, unexpected indent. And it's on line 9 here. Oh, and the semicolon, that's a JavaScript thing too. It's on line 9 here, and it says, I didn't expect you to indent because this white space matters. And the first on line 8, I essentially said to the Python interpreter, the correct amount of indentation for the scope of this if statement is 1 space character.
Okay.
Then I tried to do 2 space characters, and that was wrong. Okay, with tabs and spaces, my editor, I've also configured it to not allow tab characters anyway. Anytime I hit tab, it gives me 4 spaces automatically. So I can't actually show you a tab character. But let's say I indented 8 spaces, and then the second time, these 4 spaces here were a tab character. I'd have 4 spaces followed by a tab.
Okay.
I would still get this indentation error, even though they appear to be at the same level of scope, because 4 spaces is not in Python's brain. It's not the same as a
It's not
tab.
the same. Okay.
So we would look at it and go, that looks like it's right, but under the hood, it would give us this indentation error and tell us that it's wrong.
Okay. Thanks.
Yeah, you're welcome. And I'm sure at some point you'll encounter that error unless you turn off, tab characters. Even
Right
sometimes
now,
in here.
whatever settings I picked, it still shows when I hit tab, it still shows 4 spaces, but
Oh,
when
good.
I hit delete, it deletes 4 of them at a time.
Okay, that's what mine does too. Boom, boom, boom. Because that's usually what you mean. And it's probably context sensitive, like when you're under this if block, it knows that you're indenting because you're supposed to be creating a new scope.
Yeah. Okay.
And 4 spaces is like there's something called PEP 8, the Python Enhancement Proposal number 8, which standardized. A lot of people use it as their standard rules for how they write Python. And the rule is tabs should be 4 spaces. 4 spaces is the correct amount of indentation for any scope. Everything else is wrong. 2 spaces is wrong. 3 spaces is wrong. 4 spaces is right. Okay, next control flow is elif. Okay, so just like in if-else blocks, in elif blocks, only one of these things can happen. So these 4 blocks of code are tied together. If arbitrary number is less than 10, it'll make this comparison first. And if that's true, this will happen and it'll jump down to line 32 after that. If it's not less than 10, it'll check if arbitrary number is less than 20 and print this one. If it's not less than 20, and implicitly not less than 10 as well, then it'll do this third check. Is it less than 30? And then print this line of code and then jump to the bottom. And then finally, if the number is not less than 10, nor less than 20, nor less than 30, it'll do this. We can get ourselves into, accidental headaches here, right? Like if I screw this up, what's bad about this?
Well, if it's not less than 30, it's not going to be less than 20.
Exactly. The way I've constructed this code now, this could never happen.
Yeah.
Because it'll first check, hey, am I less than 10? And then it'll ask, are you less than 30? And if you're less than 30, this will have already been true. So you'll print here and then you'll skip to the end. And it'll make the text a lie, but. Okay, so only one of the elif blocks can happen. And this is pretty common. You have like 3 or 4 possible answers for something. And you just want to test and do the thing for the right value of that code. Okay, and then last thing you want to do with if statements, combining with not, and or. So I can say the opposite, right, is this is arbitrary greater than 10 false. That's kind of how this gets interpreted. If not arbitrary number greater than 10, which we could rewrite like if it's less than or equal to 10. That's the true inversion. But this way we just compute this Boolean value first, and then we invert it. Make sense, the not operator?
I think so.
Okay. And says if the thing on the left evaluates to true, and the thing on the right also evaluates to true, then the result of the and is true. But if either of these two things or both of these two things are false, then the and operator says that's not true. So only if both of these things are true do we print here. And then or is kind of the opposite of and. If either of these things is true with the or operator, then the whole result is true. Okay, so remember our arbitrary number is 42. Just take a second and ask yourself which of these prints. Oh, lost Troy. He's on call.
Second one?
Yeah, okay, our number is 42, which is greater than 10 and less than 50. So the second one should print. The number's not greater than 10, so this one shouldn't print. And 42 is neither less than 10. Oh, it is actually greater than 30. So this third one might print as well. Let's find out. So that the number is larger than 30 is from here. So these are the two that print from our last block.
Yeah.
Because 42 is greater than 10 and less than 50. Boom. Yeah. And the number is either less than 10 or greater than 30. It happens to be that it was greater than 30. That's the part that sent us into this if statement. Okay. It's been an hour. I think we should all stand up. I'm going to use the bathroom and get a cup of coffee. So let's take a nice little 5-minute break, and then we'll come back and look at loops and lists.
Cool.
All right.
Yeah, the only
I think I heard some talking before I had my headphone on.
I think it was just some background noise somewhere.
Oh, sweet. Okay, I need one more minute because one of my roommates broke the cardinal rule. They killed the Joe. They didn't make some Mo. Unacceptable.
That's a hilarious rule.
I want to make a drawing that is that now. Empty.
I'll send it to him.
An empty cup or an empty pot. I love that. That's my new inspiration.
Tyler, I heard your rule. If you kill the Joe, makes a Mo. It's very
Genius.
good. Very good. I told my girlfriend she's been spending a lot of the quarantine time making art, and she's gonna make a picture. I'll send it to you.
Okay, awesome. I can't take full credit. It's from an old commercial with Terry Crews called Office Linebacker. It's
very good.
brilliant.
It's from an old commercial with Terry Crews called Office Linebacker. I feel like I've seen that. I feel like I've.
Yeah, exactly. He's at the coffee
Yeah.
machine and he tackles the person. He's up on all over them, like, you know that you killed a Joe, you make some Mo. You know that.
So moving on to whatever the next thing is. This is like where we've gone to at this point is where I've gone to with JavaScript in Khan Academy. So like
Okay, brilliant.
the next step of my course that I'm on is loops. So conceptually I'm in new territory now.
Okay, sweet. Good to know. Loops are very different in Python and in JavaScript, as you'll see. JavaScript 6 introduced some stuff that's closer to the syntax we're about to see for loops in Python. Lists are very similar, but
Okay.
looping is pretty different. Jess, are you back, by the way?
Yep, I'm back.
Sweet. We're feeling good. We're stretched out. We're on the gravy train.
Yep.
Yep.
Okay. Okay, so lists, having single values is pretty boring in any programming language, right? The whole deal is we want to automate things, which means we want to do stuff that's really similar over and over and over again, really, really fast. That's what computers are mostly good at. Doing the same thing over and over again, really fast, clean and easy. So lists, are our main way in Python to have a collection of things. So we use the two square brackets to make a new list, and this is an empty list, a list with no stuff in it. This is a list with 6 values, the numbers 1 through 6. And this is a list with another 6 values, the letters A through F as strings, okay? And we're perfectly allowed in Python to mix data types. So this is legal, but if I ever saw anyone doing this, I would have to ask them why. Why is the letter G in this list with a bunch of numbers? Whenever you start mixing data types, it's hard to justify unless you have a really good reason for it. You probably shouldn't do it. most common thing in a list is a bunch of values that are of the same type because you're about to do the same thing to them. And if I try to do math on the number G, it's going to be sad. Okay, and the list doesn't enforce any special ordering. It's just whichever order we put it in. So these two were in clearly sorted orders: 1 to 6, 1, 2, 3, 4, 5, 6, A, B, C, D, E, F, G. Well, just E, F. And then here, we have 6, 1, 3, 5, 4 in a weird out of order way. That's totally allowed. And in fact, of course it needs to be allowed, because when you have incoming data from some random source, or from a CSV file that you read, or from an Excel spreadsheet that you got from a friend that you want to process, whatever, the order of that spreadsheet might be relevant, and you don't want to apply some magical ordering under the hood without telling your user, right? Does that make sense?
Yeah.
Okay. Okay, so this is how you create items, create lists with stuff in them. You use this bracket syntax also, which might be a little confusing, that you use brackets to create a list. And then here, this is saying, give me the 0th item in the variable list1. Okay, so 1, when I write this line of code, I'm assuming, or maybe it's more appropriate to say I'm asserting, that this variable, L1, is a list type or a dictionary type, but we'll talk about that in the next section. And we're saying grab 0 means the first item in the list. Okay, so arrays are 0 indexed. Array is another word for list, which means L1 sub 0 refers to this value here on line 8, this number 1. Okay, so what will this print?
C.
Okay, C is a reasonable guess.
Oh, it starts at 0.
Right,
So D.
exactly, so it's D. Okay, and what about this? Not a joke, it's real, it
Yeah.
works.
Will it print either? I'm going to guess either 4 or 1.
Okay, let's run it and find out.
Wait, what is it? What is it? It's list 3, right?
List 3, so this list. And
Yeah,
you're saying
I think it's either 4 or 1.
1. Oh, you're on the right track, but you're going to be slightly
I'll say
annoyed.
3.
Okay, Jess, you're going to say 3 right here. Okay, let's clear this out. Kaboom. Run it. Well, that's all for later. Okay, so these are our first 3 prints.
Mm.
We knew this one would print 1. We got this right, it would print D after reminding ourselves that it's 0 indexed. And -1 prints this 3. So it just goes around the horn, which is a little weird. You kind of would expect this to be -0. I think that's what you were thinking.
I was thinking that, yeah, or just 0. Well, yeah, I guess it would have to be -0 if it were going to be the last thing in the list. That doesn't
Right.
make sense.
So there's only 1 0, and it's always the 0th, the first thing in the list. And -1 is 1 off of that, but it wraps around the horn.
Yeah.
And
Okay.
+1 is 1 off of that, but it goes straight forward. This is a Python idiosyncrasy. I don't know of any other programming language that allows you to index a list like this using a negative. A lot of other programming languages will say, they'll just throw an error at this point and say, that's not real. There is no element right here.
Right.
So this is a cute little Python idiosyncrasy. It can sometimes be really useful. Pretty much you just use the -1. I don't see people using like -2 or -3 very often. You sometimes just want to see, what's the last thing in the list? Just tell me what the last thing is. Okay. In Python, we loop over lists with this syntax. So we say for, and then this is just a variable. We could give this a more meaningful name like thing or item or number or whatever it is. but I just chose the variable name I. For I in L1, print I. And we can see the results right here. It just prints the values in order on their own line, 1, 2, 3, 4, 5, 6. Remember from this list. Okay. So yeah, go ahead.
For the items in list 1, or for I'm going to stick with item because it makes sense.
Yeah.
For the items in list 1, print all of them?
Yeah, print them each one at a time. So each time through this list, we print that item. But this line of code, line 28, gets run separately 6 times. This is different from, say, I'm allowed to go print L1. Okay. And if I save that, clear this, and run the code, now we'll see I printed 4 L1. Then I printed the whole thing. Then I individually printed each one on its own.
Each thing in the list.
Mm-hmm.
Yeah. Okay. What's the \n?
That is new line character. So the fact that there's an empty line right here in my terminal, that's from this \n.
Got it.
Yeah, and this is actually common to many programming languages. \n almost always means new line. And this idea of using a backslash is called escaping characters. And certain characters, so like let's say I want to print a double quote. I can't really do that by just putting a plain double quote in here because that terminates this string.
Mm-hmm.
So if I want to print a double quote, I have to escape the double quote. And now I'll be able to print a literal double quote character there, and the string will terminate here.
It'll be like a unmatched double quote just at the end of for line 1.
Exactly.
Colon double quote.
Exactly. So let's look. Play.
Oh, okay.
Yeah, and so like say you want a backslash, you have to escape the backslash also.
Okay.
So 2 backslashes just becomes 1 backslash. Funny.
Yeah, okay, that makes sense. Thanks.
Cool. Okay, nothing different here. Loop 2, but it prints A, B, C, D, E, F instead of, whoa! Instead of 1, 2, 3, 4, 5, 6. And then L3 prints in the L3 order, right? 6, 1, 2, 5, 4, 3. Oh gosh, why does it do that? Okay, so that's looping. You can always just loop over your list of items. It's very common to do. You've got a bunch of things, you want to process them the same way, you loop over them. And just like an if statement, everything that's indented 4 spaces underneath the for loop belongs to the for loop. So, I could print I and then I could print something else, or I could do math, or, any number of lines. As long as they're all 4 indented, they'll all happen once per iteration of the for loop.
Why is it called a loop?
Because it starts here and then it executes what's inside and then it loops back up to the top of that line of code. Yeah, and there's 2 kinds of loops, for loops and while loops. I think there's a while loop at the bottom here. Okay, here's another Python helpful syntax. If we enumerate loop 2, then our for loop now gets 2 values at a time, the index value and the value of the thing itself. So remember, loop 2 is A, B, C, D, E, F. And when we enumerate, we get 0 as the index and A as the value, and then 1 as the index and B as the value, 2 as the index, C as the value. And this is also, you know, if you recall, if I go L2 sub 3, that is equal to D. And that's what this line of code is really telling us, is that the value at index 3 is the string D.
Okay.
Jess, have you seen enumerate before?
I've seen enumerate, and it was again like the double equals, a little confusion about when to be using that instead of just using a.
Oh,
Yeah, I wonder what that was. You had some weird static there.
Sorry.
Ooh, your microphone's kind of whack. I don't know what just happened. Hopefully it gets better. But yeah, so enumerate, when you want to use these are basically only when you need the index values as well as the values. And that can be, you know, it's hard to think of an example right offhand, but I've often found myself wanting to know what this value is. Oh, actually, one good reason you might want to do this is, like, let's say you're looking through a sorted list and you want to find duplicate values. Then you basically just want to look at this value and the one right next to it. So you could say, if L2 sub index plus 1 is equal to value, then, you know, do something. And in our case, the next value is the same. So this line of code here inside this for loop says, if the value at index 1 more than the current index, if the value 1 ahead of me is the same as the current value, then tell me so. Tell me that the next value is the same.
can I say that a different way?
Yeah, please.
So for the, like, if index number 3, if the value of index number 3 is 5 and the value of index number 4 is also 5, then it will print the next value is the same.
That's exactly right. And it'll do so when index is 3, right? Because 3 and 4 were the things that were the same. Or said another way, let's say L2 is equal to 1, 2, 3, 3, 5. When
Yes.
value is this 3, this will print. Which is to say, when index is 0, 1, 2. When index is 2, value will be 3. And 2 plus 1, that will be this 3.
Where's the only thing I'm missing is where we're, oh, never mind. Oh, where I was looking for, yeah, I was looking for that line of code where we're picking index 3.
Right here. Oh, down here.
That one.
Yeah, okay, so now this won't be true anymore because I've reassigned L2. Now L2 sub 3 will be 0, 1, 2, 3. This will be the number 3.
Yeah.
That will be true. But if we run this code, and scroll down to the enumerate range. Oh yeah, okay, look. I got a little error, but here is the enumerate code running.
Mm-hmm.
So 0 and 1, 1 and 2, 2 and 3, and right then, when index is 2 and value is 3, it says, hey, the next value is going to be the same. Right, because index, which is this 2.
Yeah,
plus
so
1.
so that code inside the indented if statement gets run before it loops back.
Correct.
So it prints that first before it loops back and prints the next value.
Correct.
Okay.
Yep, and so, we can nest if statements inside our for loops. That's no big deal. We're totally allowed. We could even nest for loops inside for loops. Don't worry, we'll get there. Yep, and then here we get an error. This is a good little exercise on accident. Why did I get this error? It says list index out of range. It tells us this is the line of code that I'm running. So we know that this error occurs on this line of code. And because of what we've seen, we also happen to know we get the error immediately after we printed out this 5 and 4 as the index value. So index error, list index out of range. What do you suppose that means?
Is my microphone working?
Yes,
Yes.
yeah,
Okay.
much better.
You've run out of places in your list. Like there's not a next place plus 1.
Exactly, 5 is the last value in the list. I've already printed it out. So essentially here I'm saying, what is L2 sub 4 plus 1? What is L2 sub 5? Which is, right here in theory. And it's telling me, I'm sorry, there is no number. I can't do that. I can't grab that number because it doesn't exist. So if I want to do this, I also have to know if lang sub L2, okay, I'll put an and here because we're going to combine that using and. This, if you pass a list to the len function, short for length, to the length function, it tells you how long that list is. Okay, so if I can say if index is less than the length, because you notice this thing is, there's 5 values in it. The final allowed index is index 4, 0, 1, 2, 3, 4. So as long as the index is strictly less than the length of the list, then I can check index plus 1 without getting this error. But in the case where index is equal to the length of the list, I shouldn't execute this subsequent statement. So if I check, hey, is the index too big? And if it is too big, then this will evaluate to false, and we won't try and perform this check because it comes after an and statement, and we've already got one false value, so we won't do the thing on the other side of the and statement because we already know the whole thing has to evaluate to false. This is called short-circuiting an if statement. So if I save this, clear this out, run it. Oh, I must have done something wrong. If index, oh, sorry. If index plus 1 is less than, right? Because that's the thing that I'm checking that has to be outside the bounds. I'm trying to check if index plus 1 is outside the bounds. So I have to ask if index plus 1 is the thing that's outside the bounds.
Why is it less than the length of the list?
Because when the length of the list is 5, the largest allowed index value is 4.
Right.
So the last number that'll be less than, that'll be true for strictly less than for integers, is 4. So if this thing's 4, I'm allowed to check, but if this thing's 5, I'm not allowed to check. And this will be 5. So if I go less than or equal to, it'll allow me to check on 5.
Okay, and that will also produce an error.
This will also produce an error. Yep, same error. Okay.
Okay, I think that makes sense.
And then let's just check that I'm not going insane when I do it this way. Haha, no error. Nice. Okay. This line of code, given that this printed this, what do you suppose these lines of code are doing? Knowing that this print statement is going to show hello, good, and people, and that the length is 3.
Is it creating a list?
This creates a list right here on 56.
Is it adding values to the list?
Exactly, adding values to the list one by one. So when we use this dot property, complex data types, such as lists and dictionaries, which we're going to look at next, are complex data types. And you can use this dot property to get, they're called properties of the list. And one of the list's properties is this thing, append, which is a function. And the append function adds a piece of data to the end of the list. And so we do that like this, dot append, and then all functions have parentheses like this. You know, we've seen that with print, we've seen that with len. All functions are called in that same way. So this says, make a new list, add hello to it, then add good to it, then add people to it, then print a new line, that list, and the length of that list.
Oh, okay.
Groovy?
Mm-hmm.
Groovy. Okay. Only 2 more things, and then I'm gonna give you a bunch of challenges. It'll be really fun. Very good. Yay, yay, yay. So the 2 more things are, we're gonna talk about the second kind of complex data, dictionaries, and then we're gonna talk about functions and defining functions. We've seen lots of functions being used, like the print function, .get function down here, the append function before, the length function, okay? So a dictionary is the second kind of common complex data type. A list is just an ordered set of data. You know, we first have one piece and then the next thing and then the next thing and then the next thing. Dictionaries are unordered key value pairs. Okay, so this is an empty dictionary and we use curly braces. And this will be exactly the same in JavaScript. So when you go back to your Khan Academy courses, lists and dictionaries, they're called objects in JavaScript, but they'll basically be the same. And this creates an empty dictionary. This is the syntax for creating a dictionary with stuff in it, okay? So this says, make a dictionary, curly brace, and give the key, Tyler, the value 75, give the key 1, the value 24, and give the key none, the value of a list with 3 things in it, 1, 2, and 3. And you know, any data type can be either the key or the value. Under the hood, there's something kind of funky happening to these keys. It's called a hash table. We don't have to get into the details of the hash table, but the key gets processed in a mathematical way. So it's not always under the hood. It's not always exactly identical to what you think. So like I think none gets processed into a string, and then the string none is what's actually in there. But anyway, it's a little too advanced. We have key value pairs. So we've got 3 items. This string maps to the number 75. This number maps to the string 24. And none maps to a list. Why might we want this?
Is it kind of like defining a bunch of variables all at the same time?
It is kind of like that. I would say so.
It's so that you can refer to something by, a name that makes sense is one use of it.
Yeah, let's do a concrete example. Something that you'll see all the time is like user is an object and their name is Tyler and their age is, 55. I'm not actually 55. I look great for 55, right? Their password is, 1, 2, 3, 4, 5, 6 QWERTY, because I'm really safe password user. Okay, so you have collections of data that are associated with each other. These are all things that belong to one user. But it doesn't make sense just to store them in a list. If I just had the list with Tyler followed by 55 followed by 1, 2, 3, 4, 5, 6 QWERTY, that would be really confusing data to deal with. I'd have to go look up some documentation and know what it means. But now I know that this user's name is Tyler, their age is 55, their password is 1, 2, 3, 4, 5 QWERTY. So this is a really common kind of paradigm or pattern for collecting data into.
Yeah, so whenever that user shows up, all of that other data is associated with that user's name.
Exactly.
Yeah. Okay.
Okay. So we can use the bracket syntax to grab things out by key, exactly the same way that we did for lists, except now instead of putting in like in a list, we did, list sub 0 to get the 0th thing out of that list, the first element. Now we get properties by name using the bracket syntax. So both complex object types use the bracket syntax to fetch data out of it. And again, I read this key examples sub Tyler, and we're asking our question, is that equal to key examples dot get Tyler? And this is something that you can't do in lists, but that you can do in dictionaries, is dot get. And it's almost exactly the same as this bracket notation. So in this case, this will be true. Both of these will refer to this value 75, the value associated with the key Tyler. Okay. But .get here does something special for data that's not in the list. Okay, so we saw a list out of range error in the last notepad or last example. If I go key examples sub hello, the key hello is not in key examples, right? I have Tyler 1 and none, but hello is not in there. So if I run this code, I'll get a similar error to what we got last time. Oh, sorry, we got a different error because I didn't include an S. I tried to use a variable that didn't exist. Okay, so that's a good error to get to. Name error, there is no variable called key example. You have a variable called key examples, and like I said, the computer does no work for you in trying to, I think you meant key examples. No, no, no. It just says you're wrong. Okay, now I'll get a new error. Key error, hello. This is the same as the index out of range error. It says there is no key with the name hello in this key examples variable. But if I do .get hello, I'll print this out.
You get 2 R's in your.
Yes, I do. Good catch. Okay, now if I run it, instead of printing, okay, this is where we were. This is where I just executed the code. The first thing that prints is true. That's this line of code 19, printing true. Sub Tyler and get Tyler are the same. And when I .get something, if it doesn't exist, it's happy to run it and just says none. Okay, so here's an example of a use of the none type. You asked for a piece of data that doesn't exist in that dictionary. You get none. Good?
Yeah, that makes sense.
Sweet. Okay. You can also add new keys using this bracket syntax, okay? And I should have shown you this with lists. You can do this with lists too. If I go like L equals 1, 2, 3, I can go L sub 0 equals 100. And then the list will be 100, 2, 3. Because on this line of code, I'm saying set the value at L sub 0 to be 100. It used to be 1 after line 25. It'll become 100 because I told it to. And same thing here. I can overwrite or set a new key with a new property using the bracket notation. Key examples sub new key equals new value. Now there will be a fourth key in this dictionary. The key new key. And it will have the value new value. Yeah.
So after that, if we were to print key examples,
Bingo.
then it would include new key at the end of the dictionary.
It would. And the order is unknown to us. In Python, you get no guarantees about the order of things inside a dictionary. Python under the hood is allowed to order them anyway. So it might be the last one, but it could be the first one or the second one or the third one in the printing order. Let's find out. Clear this.
Is there any time where that actually matters to you?
If you're looping over something and you expect it to be in an order, it could matter, but then you just want to, pull out the keys and sort them first and then loop over them. Does that make sense?
Yeah, thanks.
Never mind.
You sure?
Well, is there? I think I was expecting it. Maybe it's just the language, like key examples, but I was expecting it to just print the keys rather than the values.
Ah, okay.
Is there a way to do that?
There is. If we go keyExamples.keys, that's a function that all dictionaries have. And this will return a list that has the keys in it. So if we clear this out, run it again, now we'll get a dictionary keys type that has just the keys. And I think we can go values as well if we just want the values. Yep.
Okay.
Yeah, so keys and values, definitely common to use, common to want to do. And if you just print the whole thing, like you saw, it gives you the whole thing.
As they are paired.
As they are paired, yep. And helpfully, when you print it out like this, it gives you the thing in a syntax that I could copy and then paste and then have it be Python code. I could use it again. So it's kind of useful. Okay, I showed you this using .get for something that doesn't exist results in none, right? So that's the difference between get and the bracket notation. You can get none. And then the last thing that we want to do in Python with these dictionaries is loop over them. Okay, so you saw keys and you saw values. There's also this thing called items. And if I go for key, comma, value in key examples.items, I can print both the key and the value kind of on their own line, like we saw with other loops. And new key is in there, so new value gets printed out as well. Okay, how are we feeling?
I think that's fine.
I think you're fine.
It's good.
What does the dot items do again? Like what would happen if you just do for key, comma, value in key examples?
Oh yeah, great. Let's try it.
Too many values to unpack.
So I'm asking it for two things, a key and a value, and it's telling me that's too many. You're expecting two, but that's the wrong number. Okay, so let's see what happens if I just do one thing. I think this works in Python. What did it print?
Just the keys.
Just the keys, right? So looping over a dictionary by default just gives you the keys, and if you want, you can go key examples, sub key, and now this will behave very much the same way that it was behaving before. I get the key from the key examples, and then I ask, what is key examples at that key?
Wait, what?
Oh, yeah, okay. This line of code.
Yeah.
What does it mean?
It
Aren't you asking for the key again?
This is the key, but what about here, key examples sub key? That's a no.
I don't know.
Okay. This is the same as what's happening up here, sort of. But instead of assigning a value to the property, I'm saying, just fetch me the value of that property. Okay, so each time through the loop, key, the first time we loop through here, key is Tyler. So key examples sub key during that iteration of the loop is the same as going sub Tyler, because the value in the variable key is this string Tyler.
Okay.
So
Got
I
it.
have key here. I'm saying go into that dictionary, key examples, and fetch the data associated with the property Tyler, which is 75, which is 75 down here too.
Okay.
I'll copy this so we don't have to keep scrolling up and down. So essentially, the first time through the loop, key is Tyler. Key examples sub key, which is key examples sub Tyler, is 75. So this prints Tyler 75. Second time through the loop. Key is 1, the number 1. Key examples sub 1 is 24. So we print 24.
Okay.
You following?
I think so.
And then it happens 2 more times. Once with none. So when key is none, we get this associated 1, 2, 3. And when it's new key, because we ran this line of code to add that key to our overall list.
I think part of what's confusing is the things are labeled like labeled what they are, you know, like key
Oh,
examples,
sure.
you know, so that's part of what's giving me difficulties in understanding.
Is
And the
this any easier?
Maybe.
Maybe. But go ahead, ask the second part of your question.
Well then why isn't it print like X key examples sub value? Like why is the variable in the brackets also?
Why is this in the brackets?
Yeah.
Because we want that value, we want the value of that variable to be used as the key into the dictionary. Right, so if we just do X, we just get the keys.
Just get the keys.
Right. And we want to know what the value of that key is inside this dictionary. So we do that by saying X, because we want to reuse that value. When it's Tyler, we want to use Tyler. And when it's 1, we want to use 1. And when it's none, we want to use none.
Yeah, okay.
And now this way they'll print on separate lines, Tyler 75,
Right.
1, 24.
Yeah, okay. It does make sense. I would just need some practice with it, but yeah.
So that's something that confused me too when I was first looking at code, was that in practice, the name of what something is often used in the code. like key was in the brackets.
Yep.
So you just, kind of getting used to looking at it.
Yeah, like calling a key
E.
calling a key is confusing. Yeah.
Yep. Yeah, it's tricky, and it's, it goes against my better nature as a programmer to use something else because we want to use really descriptive names, but
Mhm.
when we're just getting used to what those names are,
Yeah, I see.
I
what you
totally
mean.
get why it's confusing.
Yep.
Okay, I'm going to Control Z a few of these. Go back to what we had. Okay. Oh yeah, going all the way back in time. This was a good exploration. This is the shorthand, remember, that we were exploring to more easily and cleanly get the key and the value out using dot items.
So is that essentially does it essentially the same thing?
Yes, exactly. And so if I print this now, you'll see we once again get the keys and the values. But it's a little easier to read, in my opinion.
Yeah. Okay. That was actually really helpful. That makes a lot more sense now.
Boom, sweet. Okay, last thing, and then we're gonna practice. I'm gonna make you read some code that's been slightly obfuscated by me. Ah. Okay, functions. What's a function? We've seen some of them before. I've kind of described them.
Well, functions are blocks of code that we can reuse.
Oh my gosh, that's so good. Why would we want to do that?
To make it easier to make it easier to read.
Certainly, for one, we want to collect, you don't want to just like open up your code and have a million lines that you have to read from top down. That would be awful. Jess, you gotta.
Yeah, so if you wind up copy pasting a lot, then you could put something in the wrong place and kind of break things.
Exactly. There's a principle called dry in programming. You want your code to be dry, which stands for don't repeat yourself. If you find yourself writing the same, 3 steps of code over and over again, you process some data the same way, move that into a function, and then you can test the function and make sure the function is right, and you won't accidentally miscopy one of those lines of code. You just always use the function. And I mean, again, going back to like the fundamental premise of programming, we want to do the same kinds of things really, really fast over and over again to data that's more or less the same. Every time a user shows up, we want to do the same thing with that user. Put their name in a database, hash their password, and store their password so we can look them up later. Make a new landing page just for them so that they have their little space and their friends, and then sign them up for our newsletter. Those are just little functions. Create user in database. Sign up user for newsletter, right? So we'll group those things together into functions. In the data science world, train our model. That's a function. Execute our model on this new piece of inbound data. Is this picture a cat? That's a function. Classify this picture. Is it a cat? True or false? Okay, so we define functions using this def keyword. Okay, so when I say def, that always means in Python, I'm about to make a new function. You give the function a name, just like you give variables a name. So you go def name of the function. And then you always have space, whether you accept what are called parameters or not. You have 2 parentheses that in between them are parameters. And that's data that you pass into your function. So data can come into your function and data can be returned from your function. So data comes in, data comes out. You're not required to pass any data into a function. So this function doesn't take any parameters and it just boringly computes the number 2 by doing 1 plus 1. And out of that function comes the number 2. Okay, so you can use this function down here on line 20. We say make a variable named 2. 2 gets the result of executing this function, compute 2, which goes from this line of code, jumps into this line of code, runs line 7, does 1 plus 1, and return means this returns 2, which means the variable 2, or x, gets the number value 2, because that's what 1 plus 1 equals. Okay, this function slightly more useful. Def, we're naming a function, call it add. Take two parameters, parameter 1 and parameter 2, add them together, and return that. So here on line 21, add 2 and 3 results in 5 getting returned. Okay. If you don't have the keyword return somewhere in your function, then the function will return the value none just by default. So all functions in Python return something, but that something could be nothing. You're allowed to have it be nothing. Okay, and of course we can pass variables to our function. So we created 2 and 5 by executing these functions, compute 2 and add. Then we compute the number 7 by calling add with our two variables, 2 and 5, which we happen to know have the values 2 and 5. Okay, and same thing if I clear this out, save this code, run this code, we get 2, 5, and none, and we get 7. So now you have basically seen more or less all of the core fundamental building blocks of Python, the things that all complexity is built out of. The next thing I want to do is challenge you all to read some code that you haven't seen before, and you can execute the code while you're doing that. But before we move on, let's pause for questions here. You have seen the alphabet. You now know the alphabet. You can read, children's books.
I think I'm good.
Okay, then let's look at a children's book. So you've got this open. You can open reading exercise number 1, and I'm going to give you both, let's say, 3 minutes to read this code, and then I'm going to ask you to describe it. What is this code's purpose? What does it do? This is something that actually is built into this mystery function, exists in every programming language in the standard library pretty much. So this is a meaningful function. The question is, what does it do? And you can, of course, run this code on your own machines and check out the output, but try and read it first, then run it and see if it makes sense, then go back and forth. Okay, so 3 minutes on the clock. And I actually do have a timer, so. Can I grab a coffee? Okay, beep, 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 beep. Time's up. What do we think? What do we think this code does? I think you're muted.
I thought it was going to print a number. It didn't.
Okay, why did you think it was going to print a number?
Because I'm looking at a bunch of numbers.
So the reason it doesn't print a number, it prints true or false, right? Either time.
Yeah.
Is because the only things following a word return are either true or they're false. So that's what mystery function will always evaluate to, either one of true or false. Either because line 5 executes, and at that point, true is returned from the function, and actually the function ends. Whenever it hits a return statement, nothing else happens. So even if you're in the middle of this loop and you return, loop's over, you're done. Or the loop completes, this never happened, and false gets returned. Okay, so with that new information, when is true returned?
When specific thing has a value of 4 as an integer.
Okay, in this case, right?
Yeah.
Okay, we're getting closer. Jess, do you want to jump in here? What is this? What do these 3 lines of code together kind of do?
So it's going to cycle through the first element at the 0 index in the mystery function. So it's going to go 1, 2, 3, 4, 5. So 4 thing and things is that. And then if specific thing, which is the 4, if specific thing has the same value as whichever of the numbers in that list you're going through, then it would return true.
Okay, so one more time. We call mystery function with 2 parameters. This list, 1, 2, 3, 4, 5, and this number, the second time, or the first time at least, this number 4. That means things is this list, 1, 2, 3, 4, 5. It means specific thing is this, integer 4. We're going to loop over all of the numbers 1, 2, 3, 4, 5. So each time, we're going to check if the thing we're looking at, so the first time it's 1, that's thing, and the second time thing is 2, and then the third time thing is 3. But specific thing is always 4. We never change the value of that. It was just passed into the function, and it just keeps it. So we're looping over all the things in this list, and if we ever encounter the specific thing we're looking for, we return true. And if we never encounter the specific thing we're looking for, we'll return false. Can either of you think of a better name for this function?
Find.
Okay, I like find. I might have also gone with contains, list, item. That's maybe a better way to name this function. Does this list contain this item? And then, of course, would also have to go, thing could still be thing, but I'd probably call it I in list. And now specific thing is actually item, and thing is actually I. Now we've kind of refactored this. Now I have to say, actually, list is not allowed because list is a reserved keyword in Python. It means the same thing that means, basically. So, I don't know, we could say items, but now we've got this same, somewhat items, item. Okay. Some people say there's only 2 things that are hard in computer programming. naming things and off by one errors. I disagree. There's lots of things that are hard, but. Oh, I think that joke's supposed to be there's only 3 things in computer programming that are hard. Naming things and off by one errors.
Nice.
Okay. So that's what this function is. We're searching in a list. We can go back to how it was before. We're searching through a list of things, and if we ever find that specific thing, we return true. And so, of course, the whole reason this one returns false is the string for doesn't ever occur in this list. We could make it return true. Now we'll get true twice if we run this code. Because suddenly 4 is in the list. Okay, makes sense? You want to do another one or do you want to break?
Let's do another one.
Okay.
Okay, let's do one more. All right, 3 minutes on the clock. We're looking at number 2 here. The mystery function, there's 2 of them, 2 mystery functions. So hopefully you have this up because I can't show you all the code at once without making it too small for you to really Okay, that's 3 minutes. Do you want a little more time, or do you feel good?
I definitely need help.
Okay, ask a question.
Well, so the difference in the two functions is one has an elif statement and one just has two if statements.
Right.
I see that.
Okay,
Um,
but what does it mean?
I know.
Okay, first of all, can you describe what this function does, kind of
Well,
in
I
plain English?
I thought I could, but then I looked at the student names list,
Mm-hmm.
and I don't think it does what I thought it could do.
Okay, what do you think it does?
So what I think it does is that if so for a given
A given what? What type of things is names?
there's strings,
Yes, a list of strings.
list of strings. So for a string in that list,
That's right.
if the first index number is a, that's what I think it is saying.
Okay,
Just like a.
that's close,
its
but
own.
in terms of names, assuming these are names, what does this mean? What does name sub 0 mean for any one individual name?
I don't know.
It's the first letter.
Okay, it's so that's what it was confusing. Was I thought it meant like it had to be just a on its own, but it's the first letter.
Exactly. We're extracting the first letter. So for my name sub 0 is going to be capital T.
Right. So okay. Oh, and then four is a loop. So
Right.
So it's going to read. It's going to read. Just that first if statement is going to read Tyler and count 0, and Taz and count 0, and Amanda and count 1.
Yes.
And Zeke and count 0, Adnan and count 1, Amos and count 1, Frank and count 0, and it will return 3.
Let's see what it
Wait,
returned.
well, but then there's then there's another statement.
That's right. Okay, so on the first one, right. Let's get our list of names so we can see them at the same time. Okay, so Tyler doesn't start with A, so no count. Then we know that Tyler doesn't start with A, so the next question is asked. In terms of Tyler, what's this asking?
It's if the item in the list, if the last letter of the item is Z. Is that right?
Yep. Okay, so now, can we describe this whole function in plain English?
If the first letter of the name begins with A, it will count that name. Or if that's not true, if the last letter of the name is a Z, it will count that also.
Exactly. Okay. Jess, can we, let's play golf, code golf. Can you describe it shorter than that, more simply than that?
For each name, it is checking the first and last letter, and if it matches A or Z, then it's going to increase counter by 1, and so it's going to return that.
Okay, now I'll code golf it. This function counts the number of names that either start with capital A or end with lowercase z. But it will only count each name once. So, you know, for example, Taz, whoops, I don't think we have one that, oh yeah, Amos, I did have one. Amos counts for 1 because it's true that his name either starts with A or ends with a Z.
The program would stop at the A though.
That's right. It would count the A and then it wouldn't even check to see if Amos's name has a Z in it at the last letter position.
Okay.
Okay, and so with that in hand, we identified correctly the difference between these is just the 2 characters L. How is this different?
So to use our same example, it would count Amos twice.
That's right. Okay, so this counts the number of names where at least one thing is true. The number of names that start with A or end with Z. This function counts the occurrences of a capital A or a lowercase z in their respective positions, counts the occurrences of capital A at the beginning or lowercase z at the end across all names. Meaning each letter is counted. Each occurrence of an A at the start is counted. Each occurrence of a Z at the end is counted, not just the names as a whole.
Yeah. Okay.
Okay, and then we run the code and we get 4 on the first one because there's 4 names that have that situation. 1, 2, 3, 4. And the second time through, we get 5 because there's 1, this Z counts, 2, this A counts, 3, this A counts, 4, Amos A counts, 5, Amos Z counts.
Mhm.
Frank, neither.
Okay. There's when you're doing self-teaching, you read a lot about thinking like a programmer,
Oh yeah,
and it's beginning to come clear what that means, because you have to think in the stages that that the computer reads them.
absolutely. Really pedantically, top to bottom, each
Yeah.
thing in a for loop, what's happening this time through the loop, do the code. What's happening this time through the loop, do the code.
Yeah.
So it can be really useful, especially in these types of examples, to kind of imagine. So like one thing I'll do, let's see, I can get annotate on my screen. One sec. I need this program. No, that's not what I said to open. No. You close Astro. Yeah, no, god damn it. Oh my gosh. I can do this. Okay, so what I would do is say like, okay, I'm looking at this function and I will go counter equals 0 and I'll keep that in my head or I'll write it down on a piece of paper and then I'll say for name in names. Okay, name is currently Tyler because that's going to be the first one. Okay, names sub 0, I know that's referring to this. That's not an A, so counter doesn't increase. Okay, names -1, that's an R. Okay, that's not a Z, so I'm done. Okay, now I'm exiting the for loop. Okay, so now name's not Tyler anymore. Now it's Taz.
Right.
And this is wrong. This is not thinking like a programmer. I made that a capital A because of my handwriting style. That's a lowercase a.
Right.
Different people have different problems thinking like a programmer. Okay. T sub
Yeah.
0, nope. Z, oh, okay, that is. So counter's not 0, it's 1 now. Now do the next thing on the list. Go to Amanda. Name is Amanda. Right? And doing this kind of very step-by-step process is really illuminating, really helpful.
Yeah. Okay.
Should we do the next one?
Sure.
Unclick, annotate. Number 3, shablamo. Okay, here we go. Resetting the timer. Feel free to use the technique I just showed you. Write some stuff down. Keep track of it in your head. What's happening? You ran it and get something you didn't expect. I liked that reaction.
Yeah. No.
What about you, Jess? You feeling like Lenny?
I'm still looking at it, so not necessarily.
I ran the program to see if I was right, and it showed me something I don't understand. So now I'm trying to figure out.
Yeah, I showed you this.
Yeah.
We can, that's a little confusing. We can make it easier to, in fact, I'll import something called pretty print. Okay, pprint is pretty print. And if you import pretty print, the function from pretty print, the whole library, and you run this code again with pprint. Oh, whoops, I did this backwards. From preprint, import preprint. It gives you something that looks like this, which I think is a little bit easier to read. What kind of data is this? What data type?
Oh, are those keys?
Yes.
Yeah, so we created the dictionary return value.
That's right. Yes, this is the dictionary that's returned, return value that was here. And this is what's been added to it. This is how it's been modified. Okay, does that push you a little closer to understanding what's happening, Lenny?
Well, I mean, I understand that it's a dictionary, but that's
Yeah.
about as far as I've gotten.
Okay. This here, the key is a space, the value is a 4. That is a piece of information that's about this sentence. This is a boring sentence. Is there something interesting about, spaces and the number 4?
There are 4 of them.
Okay, that's true.
So it's basically reading through the sentence until it gets to a space.
It's doing a little more than that because it doesn't stop when it encounters a space. What does it do when it encounters a space?
Then it's
Counts it.
setting the value of the counter that it's going to return.
Right. So the first time, okay, that's one way to think about this line 7 is the first time I encounter any particular character, space included, I set that value in my dictionary to be 0. And then I immediately increase it by 1. And every other time, if I've encountered that value before, I don't do this if I don't set it to 0. I just increase it by 1. Okay, so that's a little bit of a clue. Are we to the point where we think maybe we could define this sentence in plain English? What?
Would you just say that one more time?
Yeah.
First time you encounter.
In fact, let's do our walkthrough. Okay, our input string is this. This is a boring sentence. Okay,
Right.
so return value is, and I'm just going to give it the opening curly brace because I know we're going to add a lot of stuff to it. Or let's put closing curly brace down here. Okay, so this is our return value. Okay, now we go for C in input string. Okay, which is to say what? We're doing what over what?
We're looping something.
Yes, looping over.
I don't know. Is C just a arbitrary variable?
Yep. And I used C because it's the first letter of character. So for each character in this string, that's what for loops do when they're over a string. So just like when we had a list, we looped over each of the items in the list. If we're looping over a string, we loop over the characters of the string. Okay, so the first time, C is going to be equal to what?
0.
Oh, not quite.
1.
Neither. It's going to be capital T because that's the 0th item in the list of characters. It's the first letter of the string. Capital T.
I thought you were asking what the counter would be set to.
Oh, counter. Yeah. We haven't even gotten there quite yet. Sorry. So all we did was determine the value of C. Does it make sense why the first time through the loop, the value is going to be capital T here?
Yes.
Okay, so now we say if return value dot get C, which is asking the question, basically, what is the value associated with the key, capital T, in return value, the dictionary return value? But that doesn't exist yet, right? Because currently,
Right. So yeah, we're trying to get a value from the dictionary return value. But it
exactly.
doesn't have anything in it yet.
Exactly. So we get the special value
None.
None. Okay, which means return value dot get C resulted in none. So none is double equal to none.
Hmm.
So this thing happens. So that means return value sub C, which, you know, C is the name of our variable. It's actually capital T, gets set to 0.
Yeah.
That's what happens on this line of code, line 8. Then we drop out of the if statement
Right.
and immediately say add 1 to return value sub C, where little c is still this capital T. Okay, so we had 0. Now I have to use the eraser, and then it goes to 1, because 0 plus 1 is 1.
Hmm.
And then we go back to the for loop. And the second time through the for loop, we're going to get the second letter, H. Okay, so little c is no longer capital T. Now it's lowercase h.
Okay, I see where this is headed.
Okay, so now, what does this function do?
It counts the instances of a single character in the sentence.
Exactly. It counts the number of occurrences for each character that happen to be in the sentence. So space occurs 4 times, there's 1 period, there's 1 capital T, there's 3 lowercase e's.
Yeah. So like we get to the third character in the string, which is an I.
Yes,
It does not exist in the dictionary,
yes,
so it gets set to 0, but then it gets set to 1.
yes,
Then we get to the, let's see, hold on, 0, 1, 2, 3, 4, fifth character in the string, which is the next I,
yes.
and it does already exist in the dictionary.
That's right.
So it does not get a value of none because it already exists.
Exactly. So this value, instead of being none, what is it equal to?
1.
At that point? Exactly. It's equal to 1, which is not none, so it skips this if statement. Exactly.
Right. And then it adds 1 to that value.
Exactly. So now it's
2.
bingo.
Wow. Okay. And then there's another one later, so it gets 3. Wow. Okay. Yeah. That kind of extrapolating process does make things really clear, but that's a lot of it's like so much stuff jammed into like such a little amount of code.
Yes.
Yeah.
Jess, how are you feeling?
I feel like it'd be nice if there was a count function.
We made it.
I know.
There might be a built-in for this. So like a lot of this kind of stuff does get built in. Let's just quickly Google, you know, Python. Wow, let's clear those annotations first. Oh my gosh.
This is maybe kind of why Pandas exists.
Absolutely. Pandas, Lenny, you probably have not heard of. It's a library for processing data.
Okay.
But it's okay. I Google, let's see, what am I typing here? Python count. Why aren't you doing anything? There we go. Python count characters in a string. Look, it knows what I wanted to do. Oh, looks like there might be a count function. So it looks like there is a string.count function. It's not clear to me exactly what it's counting though here. Number of times a given substring occurs. I don't know why that's counting too. So it looks like the built-in count function is kind of weird.
Because the phrase is geeks for geeks and geeks happens twice. And it's looking for duplicates or something.
Ah, yes, I think you're right.
The substring is geeks.
The substring is geeks. That's right. So it's asking how many times geeks occurs in string geeks for geeks. Yeah, you're exactly right. So that's not quite the function that we've built. This is kind of useful, but if we wanted to get the dictionary that we got out like this, we'd have to essentially call that function repeatedly. So we're better off building it ourselves.
Dictionary.
I think you cut out there.
Can you hear me?
Yeah.
So we built a dictionary from a string.
That's right. That's right. We processed this string into a dictionary, and that dictionary has specific semantic meaning to us. That is to say, we happen to know that dictionary contains the number of times each letter occurs in that string.
Okay.
Okay. We've got 2 more. You want to take a little stand-up break? We've got 30-ish minutes left before I've got to take off. Or do you want us to keep plowing through?
A short stretch would be good, but yeah, I'm ready for the next one. But yeah,
Okay, let's
be good to stand up.
take 5. I'll put a
Right.
5-minute timer on the screen.
Okay.
Thanks.
Howdy, howdy. Love the photo and fast work.
Yeah, she's really quick with it.
I already sent it to my wife. Get it framed.
Yeah, yeah, it belongs above the coffee maker.
Don't worry, we'll pay you royalties. Jess, you back?
Yep, I'm back.
Sweet. Okay, let's do 2 more, and then I will send you off with the rest of the day's worth of exercises, challenges for pieces of code for you to write. And, feel free to email me if you get stuck, you have questions. I'll be around.
Thank you for that.
Of course. Okay, so number 4. And actually, to better understand what's happening, I would try running this code with the print statement both here and here separately, one at a time, not both at the same time. But try copying and pasting that line of code because it'll print different things, right? If you print it right here and you run it, you'll get one answer. And it'll be slightly different if you print it after. But anyway, read the code. Tell me what it does. 3 minutes on the clock.
Does range just mean like 0 to 10?
Yes, that's exactly what it does.
Okay.
It essentially creates the list 0, 1, 2, 3, 4, 5.
Okay.
Hey, it actually beeped this time. Beep, 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 beep. All right, Jess, you want to kick us off this time? What is happening here?
Okay, so we have C, which is just going to get incremented the entire time. So it's going to be like, let's see, it starts at 0, but then 1 gets added to it. So it's just going to be going 0 to however many times this runs. And then you've got kind of a inner loop that's going to loop through 1 through 10, but it's going to do that 10 times because it's within the loop that has I for I in range 10.
Right. Right.
So J is going to look like 0, 1, 2, 3, 4, 5, 7, 8, 9, 0, 1, 2, 3, 4, 5, 7, 8, 9, because it's going to keep looping through 10 times. And then I is going to look like 0, 0, 0, 0, 0, 0, 10 times, and then 1, 1, 1, 1, 1, 1, 10 times.
Right. So this is a very programmery way to basically count to 100. Right? Do this 10 times, but do it 10 times. 0 through 10, 0 through 10, 0 through 10, 0 through 10, 10 times 10. Going up to 100, and you can see C just gets incremented every single time through the loop. And so we end at 99. Again, we end at 99 if this thing is here. That's the way it is down here. If we change that position, then the final count, counting it actually to 100, gets included. So let's see that if we move this down here and then save it and then run it, then we actually do see that we, count all the way to 100. Lenny, does this make sense to you too, that what's happening here?
Yeah. Why? Yeah. Why does changing where the? Oh. It gets by moving the print command or print call. What's the thing? How do you describe
Yeah,
that?
both of those would be appropriate, the print command or the print call.
By moving the print command below the C plus equals 1.
Yeah, the increment.
The increment, then after it goes through all of the lists, it still adds 1 to C.
Exactly.
Which is why it gets, like, the last thing that happens is it adds 1 to 99.
Exactly. Exactly. Yep, so you can you print loops in loops, and what happens is this loop goes till its completion, and then this loop advances 1, and then this loop goes all the way through its 10, and then this loop advances 1.
What happens if, well, I guess I can do this in my own thing here, but what happens if you change the indentation of the print line?
If I just change that, then I should get that indentation error. And notice that it gets that indentation error before it even tries to print anything. It knows that this is quote unquote illegal syntax.
Oh, I meant backwards. Like if you took,
if I go here.
Yeah.
Okay, brilliant. Yes. What do you think? That's a great question.
Well, I already did it once. And it. Oh, okay. Oh, interesting. So it didn't print C until the first loop of I was completed, which meant it counted to 10.
Exactly.
I don't know why J
is always 9.
Yeah, is always 9.
Okay. This has to do with the way scope is handled in Python. So again, scope is like this function has a scope. Everything that's indented anywhere underneath that function is its scope. Everything under this for loop is in this for loop on line 8's scope, these lines of code. This is the only line of code that's on this for loop's scope. But basically, once a variable has been created in any scope in Python inside of a function, that variable becomes available above it. Which is to say, once we create this variable j, I can access it here outside of the function. So I could also say print j, and it would still be 9 on this line of code too. And what's happening here is it goes from 0 all the way up to 9, 0 through 9, that's range 10. And every time this for loop ends, j is always 9. That's essentially what it's telling us, is that j is always 9 the last time through this loop. And then it gets reset, j gets reset back to 0 once this line of code executes again and we restart the loop.
Okay, that's a little confusing.
Another way to think about it is, let's we go I gets 0 and then j, right, gets 0. We're executing these two lines of code.
Mm-hmm.
And c is currently 0, but it's about to be incremented.
Great.
Okay, so we're on this line of code. Now we know we're going to do this line of code, 10 times basically. And we're also going to do this line of code, which advances j. Okay, so I is 0, c gets incremented to 1, and then so does j after that. And then c gets incremented to 2, and so does j after that. And then 3, and so on,
Mm-hmm.
all the way until j is 9, because range 10 gives us a range from 0, 2, 3, 4, 5, 6, 7, 8, 9. It gives us 10 numbers in that range.
Oh, right, because 0 is included in the count.
Mhm.
Yep. Okay.
And so when we finally increment j to 9, that's when this
It
for
moves
loop
back to
knows
9.
it's done. And that's the moment in time that this prints.
Yeah.
So it prints us, I was 0 the first time through the list. 9, the last number of our list, is what j was. And c is 10, because we incremented it.
Yeah, and okay. Yeah.
And so, in the middle of this list, j is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But as soon as it ends, as soon as this for loop ends, it'll always be the last number in range 10, which is 9.
Yep. Okay. Cool.
Okay, dope. Let's do the last one. I think we've got just enough time. Let's clear those annotations first. Okay. This time I'm a little bit less cryptic about the names, at least. So hopefully that helps. Okay. Times up this should look familiar. But what the hell's happening here?
I can like see all of the pieces. I just don't understand how they work together.
Okay, good. That's progress.
Yeah.
Can you describe what the result is? If I clear it, what appears, what's relevant about 1, 3, and 5 as it results to these two lists?
They are. Sorry. Go ahead, Jess.
Yeah, it's the numbers that are in both of the lists.
Correct. Yes. Okay, so that is what this code is intended to do. It's intended to find out what are the items that exist in both lists. So how does it do that? Okay, so I mean, line 1, we create an empty list. And this is, again, it's the return value, cleverly named. We're going to return this. So our intent is to write code that will cause only items that exist in both lists to be inserted into this list return value. What's this line of code doing?
Creating a loop through list A.
Right, which means outer item will be 1, and then 3, and then 5, and then 6, and then 7, and then 9. Okay.
Okay.
So the first time through, when A is 1, and we can get our little annotate. Okay, so outer, wow, that's an ugly O. Outer item is equal to 1. Then we're going to execute this first thing. If contains list B, which is also B down here, conveniently, and outer item, which is, 1. And we know how that code works. We don't have to like go back up and through it. We examined that code in the first exercise. So we know that this function contains will return true if the number 1 is in list B, and it will return false otherwise. So what does it return?
True.
True, right, because we've got 1 right down there on list B. Okay, so true. And what's this second part for? Oh, and don't forget the what's the current state of return value? What's that value right now? We forgot to write it down.
Is it 1?
No, not yet. This is the only thing we've done with return value. So what's its data type? Square brackets.
None.
Oh, it's not none.
It's
Oh.
a diction. No,
Close.
it's a list.
Yes, it's an empty list. It's a list with nothing in it yet, because all we've done is create it.
So an empty list, if you're calling it that way, it's just still an empty list. I
Yeah.
guess, basically. Okay.
Yeah, it's different from none, because I can't add value. I can't call like .append on none. I can't add values to that list. But with a list, I can. In fact, I'm about to append it to a list. Okay, so the first clause of this if statement says, if the current item we're interested in, which is at this moment in time, the number 1, is in the list B, which it is. So tell us if the outer item is in that list. The second part is saying if the outer item is not in the return value. That is to say, if we haven't already found that this item is in list B and list A. The first one happens for any duplicate item that's in both lists, but we only want to return those values one time. We only want return value to contain one copy of each of the items that exists in both lists. And if we didn't have this second clause, where we're checking the return value to see if that number's already in there, then we might add duplicate numbers to the return value list. Okay, so another way to say this is, right now, when we run this code, we get 1, 3, and 5. But let's say I add the number 1 again to list B. Now, if I save and run this code, I still only get 1 once, even though it's duplicated multiple times. And if I don't have this section of the code, if I don't do that check, oh, sorry. I had to add it to the first list to create this bug. I had to add it to the first list to create this bug. Now I get duplicates. Whereas if I have this extra line of code and it's duplicated in list A still, with that check, I only get it once. Okay,
So Tyler, this
Yeah.
would be a really good example of that efficient code that I was talking about earlier. So I could, and I'm not saying I would, but I could have written that without that second part, the and not.
Mm-hmm.
Come down here, solve the duplication, and then done, use Pandas or something to say, oh, just give me the unique ones.
Absolutely.
Do you see what I'm saying? And so somebody would come behind me and say, well, that's really silly, because now you've imported a whole nother library just to make sure it's not giving you these duplicates, and you could have just added this into your statements there. So
Yes, absolutely. And I can say even one more thing about that, about the efficiency of this code. Let's clear those annotations again. Okay. Every time this contains function gets run, it's executing a loop over this list B. Okay, so I'm looping over all of those items. And then similarly here, I'm looping over all the return value items. So here's a loop, and I'm looping, and inside each of these functions, there's more loops. So that's not necessarily super efficient, right? We're loops within loops, like you saw in this previous example, that's multiplicative, right? These are two lists size 10 that results in 100 10 squared computations, okay? And if I put a third one in, if I did like 4 P in range 10, now C is going to go all the way up to 1,000, 10 cubed. So adding a for loop inside a for loop is a multiplicative cost in terms of the efficiency of our program. There are more efficient ways to write this code that don't necessarily involve looping and looping and looping and looping. And this is the kind of stuff in like programmer interviews. These are the types of questions that you get asked, write some code now. Are you sure you're writing it the fastest possible way? And so a lot of, speed improvements rely on like finding ways to avoid doing a for loop using some kind of clever trick where you can avoid looping inside of a loop and you can just do the loop one time only.
right, and the correct answer during that interview would not be no, I'm not sure, and no, I can't fix it.
yeah, typically that's true. They want you to at least be able to start identifying where the slowness might be and taking some kind of steps to improve it. You both feeling comfortable with how this code works? You're muted.
Yes.
Okay, sweet.
Yeah, this feels, all of these examples feel sort of like one step ahead of what I'm ready for, which
Mhm.
is probably a good thing. You know, it's good to challenge yourself. But I sort of needed to be walked through all of them.
Yeah.
So I'll get there. But yeah, it does make sense. It does make sense.
Exactly, and it's much easier to try and think about it and then have someone else explain it to you really nice and clear, right?
So Tyler, why were you calling this outer item? What were you thinking of as outer?
Yeah.
So in my head, this is the outer for loop, and this is the inner for loop. Right? Because
I see.
what's really happening, right, is that this for loop is getting run within the context of this for loop. So that's definitely where my brain went.
Okay, because for some reason reading that, where my brain went, was looking at those lists and trying to figure out which of those characters or which list itself was outer.
Me too.
And kind
So
of like looking at the end of the list and going, wait, that doesn't make any sense at all.
So this probably would be what you'd prefer.
Yeah.
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 Yeah, I think that's a good refactor. Ship it. That's my hashtag. Hashtag ship it.
We need a new picture.
Okay, so I want to show you before I let you go two things. These writing challenges, writing code, come with a set of simple tests. Okay, this assert statement will throw an error if it's not true. So like right now, if I run the code, I get this assertion error on race car, which says your code doesn't return the right thing. Race car is a palindrome, so this function should have returned true because race car is the same forwards and backwards. This is, you know, a little bit lightweight when you're writing real tests in a real world situation. You do them a little bit differently, but this is very helpful. And so the first thing that I challenge you to do when thinking about writing a function, writing a new piece of code, is trying to define input-output mappings. This is a really helpful way of thinking. When I call this function with A, B, C, A, it ought to, if it's working properly, if it's doing what I want it to do, it ought to return false. Okay. So I'm going to challenge you to write 3 more tests and then kind of build out a function that will do what's been described here. Okay. And the thing I wanted to show you there is something called Polya's method, which you can Google for. I like this first one that comes up as always, the Berkeley Math Department. And this is just like a little bit of a framework for how to approach solving problems. And it's useful both in just like a plain old mathematics context, and it's also very useful in a programming context. So, you know, understanding the problem, part of this is, to me, writing these new tests. Can I understand the problem by defining a new test and deciding what it ought to return? So if I were to write a new test, what's an example of a string that is a palindrome?
Like tech cat.
Tech cat.
Share a single with an A. TACCAT.
Tac cat.
Tech cat.
Yeah. Okay, brilliant. So that means, what should this be?
True.
True. Boom, we've added one test. Okay. Then when you start actually thinking about how to do this, you always want to make a plan. Okay, so what's our plan for figuring out if a piece of text is the same backwards and forwards? How can we plan that out just, without writing any code? What might our code look like?
Do you want to know, or you're being rhetorical at this point?
No, I want to know.
So we're going to compare the last and first letter, and then we're going to move inward and compare those two. So the next to the last and the second, and we're going to keep doing that.
Okay, boom. That's a good way to think about it. We're going to look at the outsides, and if they're the same, then it might still be a palindrome. Then I'm going to look one step in, and if they're the same, they're still going to be a palindrome. One step in. Okay, and then if that ever doesn't work, we'll return false. Okay, that's one plan. You can enact that plan. Here's another example.
With
Go ahead.
that plan, though, you're left like kind of with the last letter, which is
Yeah.
not a comparison. It's just a,
That's right.
that's the
So
problem.
Yeah.
you have a special case in that strategy. If you have an even number, then you just want to look until you're looking at two side-by-side letters. And if you have an odd number of letters, when you're looking at the same letter, you have to handle those slightly differently. It's good to be aware of. But you can do it. It'll still work. I mean, you can still make it work. You can write the code. Here's an alternative plan. First, I'm going to make a string that is the reverse of the string that was passed in. So I'm just going to read the string from the back to the front and make a new string. Then I'll compare the forward string with the backward string. That's an alternative plan that you can also enact and could also solve this problem. There's always lots of ways to do things in computer land, but it's good to pick a plan first and then work towards that plan. Okay, and then you code it out.
Cool.
So hopefully this is enough work to keep you busy for the rest of the day if you want it, and if not, keep you busy for Saturday later this week.
Yeah.
Anything else you want to say before I let you drop off?
Is your email address on your website?
It is, and I'm about to send it to chat.
Oh, okay. Okay, cool. Thank you. Yeah,
Yeah,
I mean, I would like to work through these. I've heard advice about once you start a language, stick with that language for a while. And I've started on JavaScript, so I'm kind of in that zone.
Mm-hmm.
But I would like to work through these also, and I know that I'll need to email you.
Yeah, you can have me anytime.
Okay.
Yeah, I'm torn about that advice. I think it's good. It's definitely good to get to a certain level of proficiency and then map that backwards. But I'm sure as we work through stuff today, you're like, wow, a lot of these concepts are pretty similar.
Yeah, and that's the other thing I heard is once you get a foundation in something, everything else is easier because the concepts are similar.
100% true.
Yeah.
Yeah, your first programming language is really hard. Your second programming language is easier. Your third and fourth programming languages, especially if they're the same style, are almost free. Once
Cool.
you speak 5 programming languages, you might as well speak them all.
Okay, cool. Great.
So the course that you have next Monday, is it the same as this?
Yes, identical.
Okay. All right. Perfect. Thanks.
You got it.
Yeah,
Cool,
thank
thanks
you
for
very much.
coming.
This is very cool of you to do this.
It's my pleasure. And if you know some people who, you think might benefit from this course on Monday, please let them know.
Okay.
Will do.
All right, have a good
Right.
one, folks.
All right.
Thanks,
Bye.
Tyler.